Sets of numbers. Okay. The first set of numbers they want you to name has a least number that is 1. So if I were going to list off this set of numbers, typically when you're listing a set in math, you can use what's known as a set brace. The very first thing I can put in there, the leftmost number, would be 1. Then it says each subsequent number is 1 more than the one before it. So the next one would be 2, and then 3, and then 4, and so on. It says there is no greatest number. So this pattern continues forever to the right. We show that using a set of ellipses. Those 3 dots, you've probably seen them in your English classes too. They're called ellipses, and in math they mean the pattern continues forever. The name of this set, they call them counting numbers unofficially, but they're actually called natural numbers. And they use just a capital N as kind of the shorthand symbol for that. The next set of numbers they talk about is really exactly like the naturals. It just says, though, the least number in this set is 0. And then each subsequent number is 1 more than the one before it. And there is no greatest number, so again, the pattern continues to infinity. So really, this set of numbers is exactly the same as the one before it, except it's got that additional member or element called 0. These are called whole numbers. And they'll often use W to stand for the set of whole numbers. The third set, this one has no least number. It also has no greatest number. So it's not only going to close with a set of ellipses, it's going to start with a set of ellipses as well, because this will go to negative infinity as well as positive infinity. It contains all the counting numbers, so the 0, 1, 2, 3, 4. It contains, or I should say, it contains the zeros, the 1s, the 2s, the 3s, the 4s of the world, and also their negative counterparts. So no in-between fractions, no in-between decimals, but it's got all like the ticks on a number line. So just going to write a random sampling of what's in here. I've got a few negative ones, I'll put 0 in there, and so on. They call these the integers. And you might think that they use I for the shorthand for integers, but I actually represents a different set that we'll talk about later. They use Z for integers. The next set also has no least and no greatest number. It contains all the integers plus all the fractions in between. So when you start getting between the ticks on a number line, then you're into this category. Or any decimal that repeats or terminates. So you can't really list all those in a set like we did with the other 3, because there's infinite fractions in between each. So it's just kind of a matter of understanding. If you see a decimal that ends or a decimal that repeats in a pattern, or a fraction of integers, or an integer, it would be in this set, which is called rational. So set number 4 is the rational numbers. And they use Q, R will be used later, but they use Q to represent rational numbers because Q is for quotient, and any rational number can be written as a quotient or a fraction of 2 integers. And the other set is all the other stuff. This has no least or greatest number, and it's completely the complement or the inverse of all the other stuff we've talked about so far. So this is all the decimals that go on forever without a pattern, like pi, or like square root of 2 or square root of 3. Those numbers, if you type into a calculator, the calculator will stop because it runs out of screen space. But in actuality, that string of decimals goes on forever without any sort of pattern to it. And those are called irrational numbers. And those get abbreviated with the I.